All right, welcome back, Geometry Honors. All right, I got my highlighter, my pen, and my calculator. I am ready. I hope you are too. All right, countdown to the Geometry EOC. At this point, we're at the end of September. I'm going to say 8 months away. All right, we left off with criteria for triangle congruence, right? Our 5 different rules that we talked about: angle, angle, side, angle, side, hypotenuse, leg. And there's one I missed. I'm sure you'll know which one it is, and you're yelling it at home. But now we're going to talk about theorems that are specific to triangles. They're not necessarily theorems about triangle congruence, but they're theorems that we need to know. So first, this should be a review. We've done this already, right? We've talked about the 4 different types of triangles. So right triangle, you're just going to tell me what you know about the sides and the angles. So think right now, right triangle. What do you know about the sides? Oh my gosh, I can hear it at home. It's got 2 legs. And the longest side is the hypotenuse. You guys are exactly right. All right, what do we know about the angles? 1 right angle. You, like this triangle, are right about that. All right, isosceles triangle. I didn't even get a laugh from my husband. All right, isosceles triangle. You've got 2 equal sides. So we'll say 2 equal sides and 2 equal angles. And those are called the base angles. All right, equilateral. We have 3 equal sides and 3 equal angles. We also can go one step further. We know all these angle measurements here. If it's an equilateral triangle, there's only 1 angle measurement that can give you 3 equal angles and add up to 180. I would just take my calculator. 180 divided by 3. Each angle has to be 60. There's no other option. So 3 equal angles and they're all 60 degrees. All right, scalene triangle. What do we know about the sides? No equal sides. No equal angles. All right, I know y'all didn't need that review. That was more for me to get me back in the geometry game, but I'm glad you helped me. All right, so let's tackle this problem right here. So in the accompanying diagram, ABC, AB is equal to 4x minus 3. Whenever they give me information, I'm just going to label it on the picture. So A to B is 4x minus 3. BC is 2x plus 7. And AC is 5x minus 1. All right, I got my triangle labeled. The perimeter of triangle ABC is 58 centimeters. So my perimeter equals 58 centimeters. All right, perimeter. Call back to middle school. Perimeter is the outside, right? With perimeter, do I add or do I multiply? I add. I'm adding with perimeter. With area, I would multiply. The whole question right here is what type of triangle is ABC? So they must give me enough information to figure that out. Well, if I have the perimeter, I know I must be adding, right? So I'm going to add this side and this side and this side. So what I'm actually going to do is AB plus BC plus AC should equal 58, right? All 3 sides should add up to the perimeter. All right, we already said that AB is 4x minus 3 plus BC is 2x plus 7, and then AC is 5x minus 1. All right, I know you are itching to combine these like terms. I won't stand in your way. 4 plus 2 plus 5 is going to get me 11x. And then I've got a negative 3, a positive 7, and a negative 1. So that's going to give me plus 3 equals 58. So my next step is to subtract 3 on both sides. And I'm left with 11x equals 55. I divide both sides by 11. Oh my gosh. 11. And I get x equals 5. All right. I boxed it like it was the answer, but are we done? Most certainly not. So if I need to figure out what type of triangle ABC is, and I'm given the sides, I need to plug 5 back in and see what these side lengths are. That'll help me answer the question. So what I'm going to do is plug them into the 3 expressions. So if AB is equal to 4x minus 3, AB is going to be equal to 4 times 5 minus 3. So AB is equal to 20 minus 3, which is 17. So I'm going to say AB over here is 17. All right, BC. BC is equal to 2x plus 7. I'm going to plug x in. So 2 times 5 plus 7, which gives me 17. So BC is 17. And then my last side length is AC, 5x minus 1. So I'm going to plug 5 in as well. I tried to do an equal sign, didn't mean to. So 5 times 5 is 25, minus 1 is 24. All right, looking at this triangle, I should know what type of triangle this is, right? I've got 2 sides that are 17 and 1 side that's 24. That makes 2 equal sides. So I got myself an isosceles. Isosceles triangle. All right, I think you're warmed up. Let's go and flip to the next page. All right, the title of this packet was the 4 triangle theorems, so I know you're ready to get to some theorems. So theorem number 1, you're going to be disappointed because you already know it. I'm sorry. Measures of interior angles of a triangle sum to 180. Again, that's something we learned last packet, but I want you to know it's a theorem that is standard with every triangle. All right, so measures of an interior angles of triangles sum to 180. And so that word interior means inside. We also know this is the 180 rule or the 180 sum rule. All right, so this diagram shows all my different angles, and if I add them together, I get 180. All right, so let's actually do some practice here. Find the measure of angle A. All right, so angle A is missing, so I need to add 70 plus 50. I would get 120, and I subtract 120 from 180 to get my missing angle of 60. What type of triangle is this? They're all different, so it's got to be scalene. There's no 90-degree angle, so it's not a right triangle. All right, it's getting a little bit harder. All right, find the measure of angle B. All right, so looking at this, I see the points A, C, M, D, and B. So we must be looking for this angle right here, angle B. All right, so I really have 2 triangles, and within my triangles, I have vertical angles, right? So I know if I can get this angle right here, I'll also know what this one is. So I'm given 2 triangles right, or 2 angles right here. 56 plus 78. And that gives me 134. And I'm going to take 180 and subtract 134. 46. So if this angle is 46, I also know that this angle is 46 because vertical angles are always congruent. So now that gives me enough information to find my missing angle B. Over here I'm going to do the same thing. 46 plus 62. I'm going to add those 2 angles together. And I'm going to get 108. Then I'm going to take 180 and subtract 108 to get my missing angle of 72. So angle B is equal to 72 degrees. So it looked difficult, but you really were just doing the triangle sum theory twice. Once for this triangle, which helped me to get this missing angle over here, and again for this little triangle. All right, example 3. 180 rule and angle relationships. We actually already did a 180 rule and angle relationships in example 2 because it used vertical angles, right? So here's a little difficult. I have an angle, but it's not inside the triangle. So how in the heck am I going to figure this out? Well, let's see what we know. I can definitely solve for this missing angle, right? Because I've got 2 measurements right here. So 60 plus 25 is going to give me 85. And I'm going to take 180 and subtract 85 from it. All right, so that gives me 95. So I know my missing angle right here is 95 because I use the 180 sum rule. Now looking at this, I see that X is a linear pair with 95. They're sitting on that line together. They're adjacent. They're right next to each other. So if they're like that, then I know that these two angles right here are supplementary, meaning they sum to 180. Right? So I can take 180 and subtract 95. And I get 85. Do you think it's a coincidence that we got the same number from our first step? It definitely is not. So when you have an exterior angle like this, it's always going to be equal to the sum of the other two angles. It just makes sense from an angle relationship standpoint. All right, flip the page over. All right, it's getting deep now. We're going to have to use our knowledge of angle relationships to try and solve these problems. All right, what I want you to do is pause the video, read example 4, and take a look at these two problems and see if you can get anything done by yourself. I'll be here when you get back and we'll work it out together, but I want you to at least try on your own first. So pause it, try it, and then come back. Okay, I hope you paused it. Example 4, Paul, Jane, Justin, and Opal were finished with lunch and began playing with drink straws. All right, they need a better hobby than this. Each one was making a line design using 3 or 4 straws. The story just gets worse and worse. They had just come from math class where they had been studying special angles, and the story gets better. Paul pulled his pencil out of his book bag and labeled some of the angles and lines. He then challenged himself and the others to find all the labeled measurements, assuming the 2 horizontal straws are parallel in both examples. All right, so looking at Jane's straw design, we are assuming that these 2 are parallel, right? So we want to find all the labeled angle measurements and explain our reasoning for finding them. So it looks like I have X, Z, and Y to find. If I know these are parallel, I also know I have 2 transversals, right? I have a transversal here and a transversal here. I also have a triangle right here. So the fun part about geometry is trying to figure out what rules we can apply to find these missing angles. So I think Z is our best bet to start with first because I've got these 2 parallel lines and it's cut by a transversal, so I know that Z and 70 are what type of angles? I hope you said same side interior. So Z and 70 are same side interior. So we know they must sum to 180. All right, so what sums with 70 to get 180? Z equals 110. So this is 110 degrees right here. This drawing is pretty small, so I might draw another drawing out to the right just so we can see it. But Z equals 110. All right, now let's take a look at the other transversal and see if we can figure out anything over here. So I've got 135 here and X right here. What type of angles are these with this transversal? I hope you said corresponding. So 135 and X are corresponding angles, which means they are congruent. So X is going to equal 135 degrees. 135 degrees. All right, so our only missing one is Y in this triangle, right? So what I'm going to do is I'm going to draw this triangle a little bit better. And by better, I mean way worse. I meant bigger. I'm going to draw the triangle bigger. Okay. So we're trying to find Y, which is up here. And I know that this outside angle right here is 135 degrees. And I know that this outside angle was Z, which was 110. All right, I think I can figure out some moves to get us Y. So looking at this, 135 and this angle right here are sitting on a line together. They're a linear pair. So I know they must add up to 180. And we'll continue this on the next video.